What's up, you guys? Page 482. We're talking theorems of triangle proportionality, and we want to be able to discuss what we know about sides that are created in triangles where at least two of the sides, like right here, these bottom two, are parallel. Now, in order to do this, let's talk about the example here. Consider the diagram. It shows a dilation of segment DE to BC. So I'm going to get some highlighters here. Highlight it with me as well. We have this section parallel to this one. And then I guess what we want to know is, how do we know that this relationship exists, specifically the relationship that they're parallel? Well, when you create a situation where we're starting from the idea of saying dilation, the problem starts by saying that DE is a dilation of BC. Dilations, last video, dilations produce parallel lines. So therefore, just that little fact right there, the last little blurb of that sentence, is that those lines, in fact, are parallel. Now, one next thing that we do with that is we say, all right, because those two line segments are parallel, then parallel sides cut by transversals create congruent angles. BCE is this angle in that corner, and DEA is this angle in this corner. And because they're on parallel lines, you got to remember back in the previous, module 2 maybe, those are corresponding angles. And corresponding angles on parallel lines, I'm going to use the angle symbol. Corresponding angles on parallel lines, they happen to be congruent. Same size. Also, the other side of this, you realize you can have corresponding angles all over the place. So maybe I'll use, same color, but I'll use two circle markers for angle CBA, right? Here it is, C, then B, then A. Put two angle markers on there. And then we have ED, oh my gosh, typo, EDA, there we go, get that typo fixed. Those are actually congruent for the exact same reason. They're angles that are created on parallel lines. So therefore, by corresponding angles, those are also congruent. And in a previous video, maybe a poster notes video, I'll kind of swivel the camera here for a second. One thing that we talked about is when, right there, when we can say that two angles of one triangle are congruent and corresponding to two angles of another, well, then we know that those triangles are similar. So put it into into words. That means that the two triangles AED and ACB are similar by angle-angle similarity theorem. Okay, so two facts from that one. Parallel lines with the sides of the triangle coming off of those two parallel lines, creating proportional sides. Does that mean that we could put our two line segments wherever we wanted to? Well, Patrick says that no matter where he draws a line intersecting both sides AC and AB, so let's go back up to the diagram. That's this line segment here, and that's this line segment here. And I'm just going to go ahead and draw that in. I'm going to draw in a line right there. That's another point. And then if I draw a parallel line like Patrick is saying, this line segment, I'm trying to make sure it's parallel to the other two. Maybe highlight it blue so it also is standing out. Color is good. And when we do that, he's saying that it'll create similar triangles. Like this little triangle is now similar to this medium triangle, which is now similar to this big, all of these shape triangle. And is Patrick correct? Well, yeah. Parallel lines create corresponding angles. Now let's go back and think about that one for a second here. If corresponding angles are created, and there's two of them in one triangle that correspond to two angles of another triangle, then that makes the two triangles similar, which takes two pairs to show angle-angle similarity. So he's totally right. In other words, it doesn't matter where you draw any other line segment, as long as that line segment is parallel to the others, then you've created similar triangles. Okay, so suppose you draw PQ, which I tried to start doing, so we're just going to go back and use it. And it's going to be parallel to CB, and it's going to intersect AC at point P. I'm going to label that up here. And intersect AB at point Q. Maybe I got my letters backwards, I think. No, I got that right. Q. There we go. So PQ looks like that. And what can you say about AP, AC, AQ, AB, well, the thing is, if you have similar triangles, you can take their sides and turn them into a proportion. That's the math you got to know for Module 3. It's right there. Take sides that correspond and write them as a fraction and make those fractions equal. So that would mean AP, as the top of the fraction I wrote down right now, is going to be equal to AQ over, let's see, AC, AP, AB. That's what we can conclude. When you create parallel lines, and those parallel lines like have sides that meet at like a center of dilation, like A, you're going to create similar triangles, and similar triangles have proportions of sides. So we're always look for fractions. That's it for 482. Thank you for watching this one. Next up is 483 with a little help from a page beyond 483. So take a look at that one, and I will see you in the next episode.